All right, can everyone hear me? Great. If you have any trouble, just kind of get their attention in the back. They'll come over to help you. First of all, thank you very much for coming to our session today. We're going to talk about architecting multi-cloud solutions from data mesh to generative AI. My name is Don Simpson, and I'm a principal technologist on our cloud and AI innovation team. And our team focuses on things like multi-cloud, data mesh, generative AI, and many other things. I want to give a chance to my colleague Devanshu to introduce himself.
Hi everyone, my name is Devanshu Budhiraja and I work as a senior solutions architect with our financial services customers. And I have been dealing with many of the financial services customers, insurance customers who are in this multi-cloud situations and wanted to build an effective data strategy. So yeah, we're here today.
All right, thank you. All right, so we're going to get started. So a few things, I want to set some expectations. Today we are going to focus a lot on cloud agnostic patterns, primarily. We will secondarily talk about AWS services that relate to the patterns that we're talking about. And then at the very end, since this is a silent session, we will have an opportunity afterwards, if you have questions, to talk in the hallway. So the first thing that we want to talk about is our agenda real quickly. We're going to go through a data strategy overview. We're going to level set. We're going to go through voice of the customer, things that we're hearing from customers. We're going to talk about scenarios and challenges. And then we're going to go into recommended design and architectural patterns. And lastly, I think we could not get away with not having a generative AI component. So the very last session or part of this will be about multi-cloud generative AI. So first of all, we want to level set here on what do we mean by multi-cloud. When we talk about multi-cloud at AWS, there's a few things that we think about. One is where you have multiple workloads, IT solutions, or applications that are running on more than one cloud service provider. So we don't necessarily put things like SaaS into that. So I think it's good for us to kind of have that understanding. The other is that we base our understanding and what we'll talk about today on the cloud maturity model, which is part of our open alliance for cloud adoption. And then it's also important, I think, for us to understand kind of primary and secondary drivers for multi-cloud. And one example for primary cloud or primary driver would be mergers and acquisitions or M&A. So a lot of times we have customers that end up with a multi-cloud operating environment because of an acquisition or multiple acquisitions. And oftentimes those acquisitions come with, oftentimes they're abrupt, right? They're sudden, they're not announced, and they happen. And there's some transition challenges that we see with customers going from diligence to integration. The other is that we see customers looking at multi-cloud for differentiating capabilities, so differentiated services. And then we also see it from a regulatory perspective. And that could be data sovereignty, that could be cloud concentration risk. These are things that we hear from customers that are coming via regulators. So as we're talking about this definition of multi-cloud, I just want to do a quick show of hands from the audience here. How many of you have data that spans multiple clouds? And that can be siloed, that can be, we're trying to integrate and correlate. Okay. And then also, if you answered yes to that question, how many of you have challenges actually achieving your business outcomes because of it being spread across multiple clouds? Okay. Almost everybody who raised their hand the first time. So when let's go into that multi-cloud approach that I mentioned a minute ago, the cloud maturity model. This is focused on people, process, and technology, right? And we believe that a top-down vision and strategy of creating data as a strategic asset or value that is created by either efficiency of operations or additional business value, we tend to think of that top-down is extremely important. So when we look at people, one of the areas that we find that our customers are struggling is with the multi-cloud skill gap, right? So we think from a people standpoint, it's important for us to upskill our employees, augment them where we can with agentic AI and AI assistance, And then also when we look at the process, right? So the maturity model, we tend to look at organizations based on possibly a CCOE, how they've constructed that CCOE in terms of specialization, whether they have specialization at individual CSP level across certain areas like architecture, platform engineering, and then lastly, technology. We tend to look at technology first because we're technologists, but multi-cloud architecture, multi-cloud services, and some recent announcements like our interconnect for multi-cloud that we just announced, those are steps that we're taking as AWS to offer services that allow our customers to operate in a multi-cloud environment better than they could before. So let's real quickly go through a few definitions here. I like to put up these two definitions because I think they complement, but they're also different enough. So the first is from Gartner. And this data strategy is really, it focuses on a few things that are really important, right? Highly dynamic process, right? And I think we all have experienced this. You build something today, you find out tomorrow that you have additional requirements, something's changed. It's dynamic. And this definition tends to focus in on the acquisition, organization, analysis, and delivery of data, right? So really about that process. Whereas you take an AWS definition here, and again, you're seeing some similar themes, right? People, process, technology, and rules. And these two, as you think about this, one is a little bit higher level, right? The other, kind of driving into the technology. And you'll start to see that in our discussion later today. We'll get into things like data mesh. We'll get into things that are federated query, things that you can use as patterns. So I'll use a few examples, some voice of the customer. In this particular case, I've highlighted the things that I think are relevant to these quotes. We talked about M&A a minute ago. I mentioned the integration phase, right? And so we hear this often from customers, right? That this is really where they struggle. With the integration, they've acquired a company, they're kind of their day zero, day one, depending on how you look at it, and they started their process, right? There's a lot of business process associated with M&A, things like workload placement strategy, like where do my workloads go? I have certain workloads in an acquisition that are on one cloud service provider. Do I migrate those? Right? Do I repurpose it? Do I replatform it? What do I do with that? And then lastly, we just get into that technology integration, right? Like, do I have specific integration patterns that allow me to bring in an acquisition? For example, connect, so that we can transfer data, safely between the two organizations without getting full network access. And what's the most important here is to come away with a proactive strategy. So I mentioned things like workload placement, right? Having intent when we make acquisitions so that we can actually be proactive about how we integrate that. The next here, we're going to focus in on multi-cloud architecture, right? This is, again, kind of a differentiated capability. Having the right data and technology in the right cloud. And there's some things here that aren't said, but that are actually present, such as data gravity, which is a real challenge, right? The more data we have in a particular location, the more data and the more applications and services we attract to that. So this becomes a challenge, right, for us dealing with multiple clouds. And this is a, kind of a leveraging differentiating capabilities. And a lot of times, we look at this when we're thinking about differentiating capabilities. We like to come in with a good understanding of why we're doing something, and I think that's extremely important when we're thinking about multi-cloud. And last quote. This one here is an interesting, observation about a lot of talk about dynamically moving from cloud to cloud and throttling up and down, and compute is overhyped. The reality is, for some workloads in some industries, that may be okay. But for a highly regulated customer, this might not be the right strategy. So again, we oftentimes hear everyone else is doing this, so I need to consider and do that. We just like to say, start with a good intention, right? What is the business outcome you're trying to achieve, and work backwards from that. So again, ensure grounded guidance, right? So make sure that you have done your research and that is this the right strategy for you? So at this point, I'm going to pass it over to Devanshu to talk about multi-cloud data scenarios and challenges.
Thank you, Don. I hope you all still hear me okay? Okay, perfect. Yeah, so as Don mentioned, and very briefly talked about the definition of multi-cloud, we're going to talk about some of the scenarios related to data and the challenges, and then how do we solve these challenges. So let's talk about some of the scenarios first. And we just talked about the data gravity. Yes, that's a real challenge for multi-cloud because the data gravity, although you would want to use, let's say, more than one cloud for different reasons, maybe because of cost or the regional availability or best of breed, whatever the reason is, the reality is that data has gravity. So wherever you have your key applications, that cloud would pull all your data towards it. And that data gravity challenge kind of discourages you from using multi-cloud effectively. So we're going to talk about how do we solve such challenges. Also, with multiple clouds, you have the data governance and control challenges. So challenges like how do we implement the governance and security policies? How do we implement the controls? Because each cloud might have different ways of doing things, different APIs, etc. And Don also talked about like mergers and acquisitions, which is sometimes I kind of call it as a forced multi-cloud situation, even if you did not want to do it. The intention was to kind of get the best out of another business which has been acquired, but at the same time, the data which we wanted to get out of that business, the time to realize or the time to monetize the data sometimes becomes a challenge because you don't have the right data architecture or controls for the two clouds. So the scenarios which we talked about, there's like no one-on-one relationship between the scenarios and the challenges. For example, mergers and acquisition can be responsible for all these challenges which you see on your right side, like gravity, governance, etc. So there's really not one-on-one kind of a mapping between them. So any of these scenarios could give you the problems which are listed here. So let's talk about some of the capabilities on how to deal with these challenges. So first of all, I wanted to ask you, has anyone heard about materialized view or federated queries? Okay, some of you probably. Okay, many of you. That's great. Okay. For those who don't know materialized view, let me give you a real-world analogy of understanding materialized view. I always like to give the example of pre-cooked meals. Sunday night we cook meals for for rest of the week, so that we don't have to gather those ingredients, those food items again to cook on Monday, Tuesday, and the following days. So in the case of multi-cloud and in case of materialized view, we have the raw data in different clouds, and instead of computing, joining the data from different sources, we pre-calculate and pre-join that data and call it a snapshot of that data so that whenever we have to refer to that data, we don't have to go to these clouds again and we don't have to recompute everything because any of the data access requires compute, right? So to save that processing, we pre-compute that and we create a materialized view out of it, which gives us the benefits of saving time. Of course, it does cost some amount of space because you have to store that pre-computed data, but then end of the day, you have to balance between the cost and the time. And I guess in most of the cases, in many cases, in fact, time is of an essence. Federated queries is another way where we can solve the data gravity problem. So another live example or kind of a live analogy of federated query, you can think about a booking app like booking.com, ClearTip, or whatever you are using. So if you realize booking.com is getting data from all different airline provider and the hotel providers without actually moving that data to any central location. So it's like a federation layer created which can crawl all these data sources through APIs or whatever mechanism it is, and it gives you the data without moving any of the data. So even though you have a data gravity problem, but in order to fix that, you don't have to like do an anti-data gravity kind of a thing, or you don't have to move the data out of your primary cloud, whatever you designate as, and then you still have the ability to access the data without doing a lot of back and forth movements. Uh, in order to solve some of the data governance and data monetization, time to value, and acceleration, another effective way is to build decentralized architectures. And we'll dive deep into more about it. How can you build decentralized architectures? What are different architecture patterns to do that? But in a sense, it's like you have data distributed across multiple clouds, and how do you create like a governance layer, a data access layer, which can talk to these different sources in an effective way. In order to capture the data lineage, which is very important because you should know where the data is originating from, where it is coming from, how do you trust that data, you got to have an effective metadata strategy and management to solve the problem of data lineage across multiple clouds. So one of the concepts I was just talking about, federated query, in fact, that kind of serves as a base for materialized view and in some cases decentralized architectures as well. So Innovate enables these architecture patterns. So let's talk about the practical examples of materialized view. So today, actually, there are different cloud providers have different ways of defining materialized views. For example, Google Cloud has BigQuery Omni to define materialized view. Amazon has something called S3 and Athena to support the materialized view. So it has got the support for the Apache Iceberg tables as well, wherein it can refresh your materialized views. And then again, federated query can also be created, let's say using Athena federated query, wherein we have a built-in connector for Google BigQuery. So you can actually choose the data source as BigQuery within Amazon, and using the Athena connector, you can access that data without moving that data out of Google Cloud, right, sitting in the AWS cloud. And same thing you could do with Google Cloud. So it's like kind of an either-or choice. Wherever you want to build the federated query architecture, depending on what's your primary, what's your secondary cloud, and where is the data architecture, like where is the majority of the data sitting. So as I was talking about decentralized architecture, you may have heard about this word data mesh or data fabric. Now, data mesh defines a way to share the data between different cloud providers or between different data sources by calling data domain owners, or by creating data domain owners, treating data as a product, wherein each domain owner creates their own data products, and there are consumers who would consume that data product through the data mesh architecture, and we'll just talk about in a bit more detail in the next few slides. And then the metadata catalog is again, as we just talked about, how do you effectively manage the data across different cloud providers. You should be tracking the metadata for that data, like the size, the origin, how do you access it, using different cloud native tools or the third-party tools which can work across different clouds. So let's dive a little bit deeper into the data mesh architecture. So in a typical data mesh architecture, you create a data marketplace, like a central data marketplace, wherein the producers of the data would create the data sets. And I'm just going to take an example of an insurance company again, because I have been dealing with a lot of insurance customers. So think of if an insurance company wants to create a data mesh, think of data producers as one of the teams which is responsible for the management of the customer data, for the policies, for the claims. They're creating a lot of data about the customers and the insurance policies. And then on the right-hand side, there are consumers of that data. The pricing team may be, the marketing team may be, who wants to consume that data and see how effectively they can sell the insurance policies to the new region, to the new customer base. The team in the middle is enabling both the producers and consumers with that data marketplace so that they can all share the data uh, boundaryless. Like even though the data is sitting in different clouds or different sources or on-prem, uh, the abstraction layer which we are creating with the data mesh enables the boundaryless data sharing. Uh, so there are some trade-offs, some obviously pros and cons with this architecture pattern if not done correctly. Um, so the autonomy of the self-service BI or the self-service data access through data mesh, uh, that advantage can sometimes come with the cost of data silos because different domain owners, like in our previous example, the customer relationship management team or the policy or the underwriting team, they sometimes create overlapping data sets which already exist, duplicate data sets, and sometimes they create data sets which are not which other teams are not able to use due to strict compliance issues. So we got to be very careful when we design a data mesh that we have agreed upon principles, we have agreed upon standards. How do we want to create data sets? How do we want to share that? It shouldn't become a technological or a systematic challenge for the other teams to consume the data which has been produced by the data producing team. If we don't do that, then we end up creating many data sets which could be duplicate and create silos. Likewise, for standardization, like data mesh creates a standard for creating, sharing data, producing data, and the marketplace and everything. That requires a lot of upfront engineering complexity to begin with, and oftentimes, there is a lack of support from the leadership. There is technical support, the limitations around the capabilities. All these things must be considered before we jump on to create a data mesh strategy. And it gives a lot of control and flexibility when you create data mesh versus the central data architecture when you're dependent on the IT teams. This control and flexibility, because you as a domain owner, as a data owner, you can define your own data sets and you can create your own data sets and you can let the other teams access. Now, this control and flexibility also can sometimes come with a cost of inconsistent implementation between different data teams, between different data owners. Because one team might want to, let's say, create some security controls, some encryption, whereas the other team may not be able to follow those controls due to their own limitations. So let's talk about the other architecture pattern, which is federated query. So in case of federated query, we submit a query to a federated query engine, and that engine has some of the core components. Like, for example, metadata management and discovery is one of the key components. Now, this query engine actually maintains the metadata or the technical data about your data sets. Things like where data exists, what is the size of the data, how can data be accessed, all these things are defined here. Because this information is already there in the federated query, your query actually knows how to fetch that data. And similarly, it also has a data access and security layer. In this layer, we define, let's say, I have my primary workload in Amazon and I have secondary or maybe some data analytics related workload. I want to push it out to other cloud, let's say Google Cloud in this case. So I should have the right controls configured in Google Cloud and in Amazon, like the right keys and certificates, API keys and whatnot within this layer so that I can access data seamlessly without doing any sort of manual intervention or without any dependency on the IT teams to configure permissions manually. And then the last layer or the last core component of the federated query engine is the optimization and the performance, which is very important in this case, especially in case of multi-cloud, because there could be a lot of back and forth data traveling over the network. So there has to be the right set of configuration settings in order to optimize how do we let that data travel faster and in the most cost-effective way, saving the egress cost and the network cost when we want to enable the federated query in case of a multi-cloud. And as a result, when the query travels through these core components function in tandem with each other, you get the result of the query. And I would highly encourage, try this out with Athena connector for Google BigQuery. It's seamless, easy to configure, and you would appreciate like the qualities of the federated query and the advantages of this pattern. So like every architecture pattern would come with its own pros and cons, if not configured correctly. While there is less amount of data movement in case of federated query, because we are just pulling the data from a remote source rather than getting the data or copying that data from that source. This low data movement can come with high latency, again, if not configured properly from a network point of view. And we just announced the network connectivity between Amazon and Google Cloud. So I would highly encourage to take advantage of that. And we have the experts here who would want to talk about, maybe after this session, if you have any questions about this newly launched capability. So when we create a catalog, the metadata and everything, which goes into that catalog, there are sometimes metadata sync issues. Issues like, you dropped something, let's say, in other cloud, and in your primary cloud, that definition of the table, when you dropped it, or you altered the definition of the table, that was not synchronized in the metadata catalog. So your federated query engine would not know the data has changed. So if you don't synchronize it, if you don't have a mechanism to synchronize those metadata, then you would end up in a challenge wherein your query might give you incorrect results, or it may give you some sort of runtime errors. And same with the access control. That's true as well. When the permission changes between the data sources, then you got to have a mechanism in place which can update those permission sets. And it's sometimes complex to manage those credentials, rotate the certificates, rotate the keys, update the keys, and all these things. So you should all be considering all these factors before you create the federated query architecture pattern. So I think at this point we will talk about the data augmentation from an AI standpoint, and I'm going to hand it over to Don.
All right. Thank you, Devanshu. All right, so first, we're just going to level set. Many of you may be aware of what RAG, or Retrieval Augmented Generation, is. Just to kind of walk through this for people who do not know, we're going to take a user query in, kind of step one here. We're actually going to do a vector embedding of that query, ultimately to achieve and execute a semantic search against a knowledge base. So that knowledge base, we're going to do that similarity search based on cosine or Euclidean distance. We're actually going to come back with document chunks that are relevant, that can be fed in as facts, if you will, into the context, and ultimately we'll get an augmented prompt that comes out of the RAG engine. So you can think of that RAG engine in this discussion today as being an AI application, RAG engine. So those are kind of the basic concepts we want to get across first. Next, we want to start talking about what that could look like in a multi-cloud context. Now, as we talk about these patterns, we always want to kind of start with a backdrop of they're always, security is top priority. So things that we need to think about are security. We've got performance, as Devanshu was mentioning earlier, latency in the network, right? So things that we want to take into consideration in terms of design. But as we're looking at this, one approach that we can take, if our CSP1 is where our AI application or RAG engine is, we could have our knowledge bases, again, data gravity. We don't necessarily not want to or cannot move the data, so we can leave that in CSP2. But there are some key considerations that we need to be aware of. One is consistency of our embedding model, that we're using cross-cloud. And then secondarily, vector store. And they don't have to necessarily be the same, but there's opportunity here as we think about highly available systems and resilience, where that vector store could be replicated. right? So we could replicate that data store either on the same vector store on the same CSP, or we could replicate it across. Things like S3 vectors as a cost-efficient mechanism for storing vectors is one potential source or destination for that. So as we're thinking about that, there's some benefits that we need to think about, right? Minimizing the data movement, as we were talking about, so similar to the same strategy we're taking with things like federated query, but there's always those considerations, as I mentioned, network, latency, security. But again, that consistent embedding model you have to have across your two CSPs. And then again, that kind of that resiliency, right? Vector store replication and potential sharding that we want to take into consideration. We want to talk about a couple of other additional types of RAG. So first, we're going to talk about structured RAG, oftentimes referred to as SRAG. So in this case, kind of following our similar flow from before, we have a user query that's coming into our structured RAG. We're doing a text to SQL in this case. And currently, as just one example, we have databases and data warehouses. Could be a federated query engine, right, that we're querying. And today, Bedrock is an example with our knowledge bases. We support structured RAG with Redshift. So think of that as kind of a particular service that you could think of implementing. So again, in this scenario, we're executing that query. We're coming back with retrieved records, and then we're actually creating that augmented prompt from that. So there are some benefits here. So again, we're actually, instead of just being able to do a semantic search across unstructured data, now we're actually bringing in structured data that we have in our enterprise. We're also leveraging those database, the investments that we've made in those assets, right? And again, we're not having to necessarily move them, right? So this is really, when you're thinking about like scenarios like M&A, that becomes, one mechanism that you can leverage to start experimenting. Again, consideration, security, network reliability, and performance are always things that we want to take into consideration. I want to touch on another pattern for RAG, which is graph, right, or graph RAG. And what's interesting about this, as we go through it, I just want to talk about a couple of things that are going on here. So graph RAG, the biggest benefit is that we are getting to concepts, right? So we have concepts in a graph that can relate across different document chunks, right? So we're able to span beyond that kind of document scope. So we're getting the ability to do hops, iterate over relationships and traversals, right? And in this scenario, similar to structured RAG, we have a user query coming in, and we're going to a text to a graph query. So that graph query could be Cypher, could be Gremlin, could be Sparkle, and we're executing that against a graph database. So on AWS, we have Amazon Neptune as a graph database that you can leverage. Currently, this is supported with Bedrock knowledge bases. There is the ability to have graph RAG and Neptune as your store, your vector store. And then thirdly, we've got this retrieving the graph, and then we're going to the augmented prompt. One other scenario to think about in a multi-cloud graph RAG scenario is the graph and what's in there, those concepts and the relationships and what they point to. We don't necessarily have to move all of the data, right? So you could think of this, and sometimes customers will refer to this as a semantic layer, but you have the ability to create that connective tissue across the data, and that data may not live in the same CSP. So we think this is a really good implementation and pattern for certain use cases where you want to achieve that and you want to leave the data where it sits. So primary benefits, as I mentioned, the ability to traverse those entities and relationships. So you can think of that as, spanning, and trying to iterate over relationships. That could be, going back to kind of the financial services, that could be an anti-money laundering scenario. That could be a know your customer, right? So think of those traversals that you would make from an individual or person through additional associated identities, bank accounts, locations, et cetera, right, to kind of ground that. But some key considerations, again, same considerations tend to pop up here, right? And when we talk about network reliability and performance, and I know we've said it at least twice, but we're going to say it again, and that's the multi-cloud, our interconnect product. That reliability on the network becomes key, right? The performance of that is something that we think is extremely important and beneficial to our customers. So now we're going to talk a little bit about multi-cloud from an agent perspective. So as we roll into this, and we've built this up in a very structured way so that, data is key to our agents, right, in terms of their ability to perform, generate accurate results, reduce hallucination, etc. So we're going to talk about model context protocol as just being one standard, a very popular standard for allowing agents to leverage tools, right? So MCP, many of you probably have heard that. In this scenario, let's assume a few things. We talked about federated query before, and we talked about some of the trade-offs, but one of the trade-offs and things that you'll have to consider is, what if your data source is not supported by your federated query? So let's say Amazon Athena, which allows you to do federated query, doesn't have a data connector for a particular database, right? In that scenario, you either have to build a custom one, or as an alternative, you could consider an MCP server that actually implements tools and allows you to expose data from a data source. So on the far left here, I'm going to kind of fill in the picture a bit. We have an agent. We could use strands as an agent framework here. Let's just assume we are. We have an MCP server. And in this case, we're putting the MCP server close proximity, right? We want to localize and optimize the efficiency there, take advantage of, the network boundary being close, same partition. Associated with CSP1, we've got an MCP server there. And then let's say we've got another one over here, an MCP server 2 that's with our data store 2. So MCP has a client, and so we have a client for each one of those, and you can imagine that our agent is now capable of leveraging MCP to actually federate that access to the data, right? So that tool, we can go beyond just kind of access to data, we can do other things, but in this context, we're really talking about gaining access to the data, right? So could be read, could be write, depending on the MCP server. By leveraging the protocol, it could be just about any agent out there is going to support MCP, right? So we've got access, we've got interoperability, and then also we're leveraging streamable HTTP transport. So everything here is standard, right? But we're leveraging the best of, MCP servers, the wide support that we have across many different cloud service providers. So let's go through some of the challenges. We talked about data gravity. That's kind of our constraint. That's what we're trying to work around here. I talked a little bit about the data source compatibility. Take it one step further. For example, there may be a discrepancy in terms of data type support. One may not support a blob, just as an example. These are scenarios where you may have to consider something else. And then in this case, the agents can access the relevant data, right? So it gives us control over what happens with that MCP server. And then from the benefits, as I mentioned, the standard and widely adopted protocol, that locality optimization, and quote-unquote federated tool execution and processing. All right, so next we want to talk about a scenario where you have a model that may or may not be supported on AWS in Bedrock. Maybe it's not supported in a particular region. Maybe there's a capacity. So you want to gain access to that LLM in a different cloud service provider. So we're introducing the concept here of how an LLM gateway and router can help us in a multi-cloud context. Right, so this LLM gateway and router is actually going to provide us a standard unified interface on the input, the request side, Commonly we'll see OpenAI as the standard for that. Light LLM. We also have Agent Core Gateway. So we've got a couple of different scenarios, things that we could leverage here that are services. And in this scenario, we've got our agent actually communicating and leveraging different LLM, different models that are running in different cloud service providers. So as I mentioned, a lot of times these are the driving factors, right? So model selection, availability, and capacity. Also, being able to round robin, right, to the various LLMs, right? If one is not available, throttling, etc., we can actually send that to another LLM. So again, these are the primary benefits. So that specific protocol. So I have a unified, writing to one request, format, specification, and then I'm having it translated for me. I'm prioritizing and routing. So one of the other things that we can do with this gateway, depending on how much functionality we want to put in there, we may want to introduce a cost-based routing, right? So based on cost, based on the request, we can route that separately. Based on different features and capabilities, and then as I mentioned, that dynamic load balancing. And then lastly, just to kind of bring the whole picture together here, both of these, the LLM gateway router and the MCP client to server communications that we talked about in the previous slide, all of that can be utilized by an agent. So we'll just talk about a couple of next steps and resources that we have. So there's many different sessions that we have. Kind of a 101 starting with, a lot of the best practices from a multi-cloud perspective. We also have some deeper dives, right? So 200 level conversation here today, but we have a 300 level that'll actually drill down into more detail of the things that we were just talking about with respect to generative and agentic AI. And then we've got security best practices, network best practices as well. So a few other things, we have a kiosk in the expo hall that you can actually visit. We've got demos, we've got some use case deep dives. We can have conversations with you. And then as a program, the multi-cloud program, we spend a lot of time talking to customers, just like you all, about multi-cloud strategy. So happy to engage with you all via your account teams. So feel free to reach out to us. And then lastly, as I mentioned earlier, if you have any questions, we'll be available in the hallway to actually answer any of those. Thank you.